I've got a few comments on what Doug said. The first is that garbage in, garbage out is easy to guarantee until you come across some valid input, and then you've got to produce some valid output. And having a sort of validator that really guarantees valid output is quite difficult, or at least it's something we don't have yet. The second thing, I think this is a bit more interesting, which is when an aeroplane, a model of aeroplane, or even an actual aeroplane, takes off for the first time, we expect it to fly, or rather, we're in trouble if it doesn't. And I think that was part of the success of the Wright brothers, was they made small incremental steps, small step, small step, small step, small step, so that every time the plane went down the run, went down the ramp, and did its little hop or whatever it did, it wasn't catastrophic, and they're able to see what it was doing, and they're able to say, well, that's right and that's wrong. So when the first 747 went down the runway and took off, on the one hand, it's an enormous surprise that it should, and on the other hand, it should be an enormous surprise that it doesn't. And we sort of have this problem with LaTeX files, or when we process LaTeX documents, it's sort of, well, will it or won't it? And that seemed to me, in part, what Doug was talking about was, well, will things work or won't they? And the whole point of engineering is that we know it will work, that we build it and it works, that we build the bridge and it stays up. We create the motor car and it starts and it runs and it stops. I told somebody, a Russian mathematician, Vladimir Arnold, said that mathematics is that part of physics where experiments are cheap. My astrophysicist friend said, well, astrophysics is that part of physics where somebody else pays for the experiments. Now, if we're doing software engineering, we expect things in production to work. We expect operating systems when in production to work and not fall over. And in a certain sense, we haven't reached that point yet with the macro layer of LaTeX. And I would say that part of the problem is that we'll never get there until we define in practice what is for us the LaTeX input syntax. Because then we can say, well, we've created something that meets the syntax. There must be a problem in the LaTeX macros. It's just as if the operating system crashes, it's not due to any error in user space. A user space error should not crash the operating system, and a syntax error or markup error in the input shouldn't cause LaTeX to go wrong. I'll stop. I think I've gone off topic.
Well, if you look at the chat, I posted 4 lines of tech, which when I was implementing the lowercase, CS operator, I was trying to test whether I was doing it right. So I wrote those 4 lines and I could never figure out why they weren't working. And, it looks all reasonable. It's commented. The comments are a little bit misleading, but it ends up being an error that a normal, naive user would make because of the efficiency in tech of allowing an equal sign to be elided during a definition. But so there's just little things about the language that are going to be really hard to kind of understand for an automated system. Anyway, that's the code I posted is an infinite loop, but it doesn't look like it. Doesn't have a loop in it.
Yeah, it's always bothered me that in tech, if you see something like \A \B, this can have multiple meanings. It can mean that A and B are macros that do some typesetting. It can mean that A gets the value of B, or it can mean that B is actually an argument to a macro A that expects an argument.
Yep.
And these are three very, very different activities. And to make matters worse, the LaTeX implementation will do things like at the user level, define a macro with, say, 2 arguments. But in the implementation, one of those arguments will then be prefixed by some macro that appends it to another long list of arguments. And this gets extremely hairy rapidly. So at the user level, it looks relatively clean, but the implementation details are frankly horrid. And perhaps there isn't any alternative to this, but it does lead to plenty of confusion when you're trying to debug someone else's macro package.
I sort of feel that there's a topic for another discussion coming out of this. Something along the lines of building a reliable front end to tech. The macros, I think, are they a front end? They're certainly a pre-typesetting. They lie between the document and the typesetting process itself, largely. The output routine is a sort of post-typesetting or later on. But certainly, what's the word? Achieving reliability in the tech system. So part of that would be the durability, getting the same results from the same outputs and knowing when the outputs are different. And I think one of the big problems is, if I change this, what will happen? The functional programming advocates say, well, functional programming is great because all the code you write, every piece of code you write, is guaranteed not to have any side effects, because there's nothing you can assign to. And so there are no side effects. It's simply, here's the input, here's the output. And that's why it's called functional programming, because everything's like a pure mathematical function. Whereas with LaTeX, if you sort of make a change somewhere, things can happen, things can be changed all over the place. There was a query I saw on Tech Live, I think. Somebody complained about how the ISBN didn't come out properly on their book, and they only discovered it just before it was about to go to print. So the police have discovered it earlier rather than later. And it turned out that somebody had made what they thought was an innocuous and this can't break anything change at some point somewhere, and it did break something. So achieving the struggle for reliability and consistency is something we might want to talk about at another tech hour.